Hey, hi guys. Um, so in this particular video, we will be going over the plan of action for this channel. So what we will be doing, and over the course of next 3 months, I will be making some videos around the following topics. So one thing that I have planned to do is Um, so there is a lot of hype on Chat GPT right now, which is a particular, which is an application of a an area research area in um, natural language processing, which is natural language generation, which in turn is a um, sub part of generative AI. But to be honest, I know very little to nothing in this particular domain, natural language generation. But my research area was mostly on computer vision, and I have planned to make videos on generative computer vision, in contrast to natural language generation. So in generative computer vision, I have planned to make videos on stable diffusion, um, which will be followed by a project. So the end result will be a project, and and the so there will be a proper GitHub repo and uh, a playlist that could correspond to stable diffusion. That's one. The second thing is I have planned another playlist that would run for the course of next 3 months. It will be around graphs, mostly oriented towards competitive programming kind of graph theory. Um, so here is the plan. Initial videos will be on intro to graphs and trees, the basic stuff, followed by tree traversal and DP on trees. On DP, DP on trees, there will be two particular techniques or types, I would say, that we will cover. This will this will come with problem solving as well, not just theory aspect of it. So we'll be solving lots of problems. So the problems will be taken from uh, code forces, CACS, and CP algorithms. These particular platforms. Um, Following which we will go over concepts like tree hashing, and particular problem category that we will be looking into is tree isomorphism. For example, given two trees, how do we know if those two trees are isomorphic or not? Um, then we will see um, problems on checking if a graph is bipartite or not. This is based on a particular idea called as graph coloring and DFS. Um, Also, we will be looking into binary lifting kind of ideas, and the kind of problems that this solves is finding the kth ancestor of a tree, or more in a more generic sense, kth ancestor in a DAG kind of situation. Not DAG, I would say all the nodes in the graph will have exactly one parent, or at most one parent. So if we don't consider the root, then at most one parent. So following which we will be looking into techniques such as rerouting technique. This is a cool idea. We will be looking into um, problems such as invertible functions, um, also some other category of problems that would consider non-invertible functions, and how do we go about solving them. There is a subcategory in rerouting. So there are two ideas. One is based on nodes, and the other is based on edges. Most people know about node rerouting, but edge rerouting is something very less popular among competitive programmers. So we'll be looking at that particular kind of trick. And once we know that trick, lot of hard problems in competitive programming would seem very easy and very intuitive as well. Following which we will be going over BFS kind of techniques. So BFS, some particular ideas are 0 1 BFS, multi-source BFS, pretty neat stuff. Um, some shortest path in unweighted graph ideas, flood fill ideas. We will also look at some graph modeling questions as well. Um, so then also some other standard techniques in graph theory such as Dijkstra that solve single source shortest path problems. Bellman-Ford, which is a dynamic programming counterpart of Dijkstra. And then we will also go through some reachability problems and how we go about solving them. Um, Floyd-Warshall is one of the many techniques that is generally used to solve reachability problems in graph theory. In particular, Floyd-Warshall solves all pair shortest path kind of problems. We will look into the broader class of solution category, which is called as matrix exponentiation DP ideas. Um, some other known techniques that we will look into are topological sort and DAG ideas. Note we will solving lots of problems, not just theoretical aspects of this. So yeah, stay tuned for that. We will also look into implicit relations and topo ideas kind of questions. So Kahn's algo is one algorithm that solves topological sort questions. This is based on integrity and this also uses BFS kind of technique. So BFS, it is based on BFS technique. One more solution to um, this topological sort is based on uh, DFS kind of technique. So we will look into both the ideas and what kind of problems each of them solve. Moving on, we will look into graph condensation, bridge and articulation point ideas. From here on, we will look into some advanced graph and advanced tree concepts. Um, so graph modeling is a it's a very abstract concept, and many questions in code forces, pretty hard questions are modeled around this particular idea, where we add a dummy node or add some dummy edges and um, kind of this is the creative part in graph theory, and lots of cool problems are based out of this. Following which we will go over binary lifting again. We will revisit this, and this particular category solves path updates on tree kind of problems. Um, Following which we will look into something called as auxiliary trees. It solves a specific type of problem in path updates on tree problems. We will look into that. We will solve these questions. We'll code them up and solve these questions. Um, then we will look into ETT1, that is Euler-Tour Technique 1, Euler-Tour Technique 2. So Euler-Tour Technique 1 is generally used to solve subtree queries and update problems. So we'll use segment tree to solve them. Um, so and then in range updates on trees, we will use Euler-Tour Technique 2. Um, Finally, we will look into heavy light decomposition (HLD), and we will see how using HLD and Euler-Tour technique we can solve pretty high-rated problems in code forces such as div1 EF kind of problems. We will also look into techniques such as small to large merging. we'll solve many problems around that idea as well. Um, Finally, we will look into Moson trees, centroid tree. These are even I would say hard concepts, but we will look into the intuition behind these and we'll solve concepts. So at the end of all this, we will be solving a lot of hard problems on them. Finally, we will see centroid tree radius query kind of techniques. We will solve problems from code forces, CP algorithms, and CSES on these ideas. We will also look into the last technique, that is edge decomposition tree. There are very hard problems in div 1, E and F, which we will be solving. Um, so stay tuned for that. So finally, I had add these two type of techniques. That is, I mean, essentially it's one technique, DSU, disjoint set union. We will look into how many problems are modeled around them. We will see how MST, in particular Kruskal, is using DSU to solve lots of problems in this domain. So yeah, that's very much all about this video, and stay tuned for the videos. Yeah, thank you.